Have you ever wondered, after nearly a decade of endless promises about clean trucks, electric trucks, and hydrogen trucks flooding social media, which technology is actually out there on the road right now, hauling real freight and making real money for the biggest trucking companies in America? It is not the company people talk about the most. It is not the company with the loudest CEO on social media. For years, people believed the clean trucking revolution would come from battery electric trucks or hydrogen fuel cells, two paths that attracted tens of billions of dollars and thousands of hours of media coverage. But while the whole world was staring at those flashy announcements, one engine company that is almost invisible to the general public quietly put thousands of trucks powered by a fuel once considered outdated onto real roads, and it is already preparing for an even bigger next step. This video is a story that goes against the current, a journey to understand why Cummins, a name tied to heavy-duty diesel engines for more than a century, is becoming one of the biggest unknowns in the future battle for heavy-duty transportation. As you already know, heavy-duty freight makes up a huge share of America's emissions because diesel prices affect the cost of almost everything on supermarket shelves, and because in the next few years, hundreds of thousands of trucks will have to be replaced as the strictest emissions rules ever officially take effect. Whoever leads this race will help decide how much you pay for every meal, every package, and every shipment delivered to your front door. And here is the detail very few people are paying attention to. While Tesla spent almost a decade trying to move the Semi from a drawing board to a real production line, and while Nikola, a company once valued at more than $30 billion, collapsed and shrank down to only a few employees, Cummins quietly did something almost nobody noticed. It put an engine with no battery and no hydrogen fuel cell into real-world operation across tens of thousands of miles every single day, and it already has a plan for what comes next. So what makes this path so different? Why are massive freight companies like UPS betting on it, even while they are also testing Tesla's electric trucks? And could Cummins' next move, a hydrogen-powered engine that almost nobody is talking about, actually be the thing that ends the diesel era? Or will it become just another unfinished promise? Before we dive deeper into the story, if you enjoy analytical videos like this, do not forget to subscribe to the channel so you will not miss what comes next. When the whole industry bet on two paths and forgot the third one, to understand why this story matters, we need to take a step back and look at the bigger picture of America's heavy-duty trucking industry. For more than a decade, the trucking industry has been living under the pressure of one major deadline: the 2027 emission standards set by the United States Environmental Protection Agency and the California Air Resources Board, the strictest nitrogen oxides and carbon dioxide limits ever placed on heavy-duty trucks. Every engine maker has to find a way to meet them, or walk away from the largest heavy truck market in the world. In that environment, two paths rose up as the so-called obvious answers. The first was battery electric, stacking thousands of battery cells under the floor of the truck and removing the internal combustion engine completely. The second was hydrogen, but not by burning it directly. Instead, hydrogen would be turned into electricity through a fuel cell, a technology that sounds like science fiction stepping into the real world. Both paths received enormous attention. Tesla introduced its Semi in 2017 with a promise of 500 miles of range. Nikola, another startup, was at one point valued higher than Ford Motor, with ambitions to build its own private network of hydrogen fueling stations across California. But both of those paths ran into a problem that was not really about technology. It was about pure physics and economics. Heavy-duty trucks need to pull loads of 35 to 40 tons, drive hundreds of miles a day, and refuel fast enough to avoid disrupting delivery schedules. A battery big enough to pull that kind of load can be so heavy that it eats into cargo capacity. Hydrogen fuel cells require a fueling network that basically does not exist, and the fuel cell technology itself is still expensive and fragile under harsh operating conditions. While the whole industry was shining its spotlight on those two loud paths, one company chose a completely different road. Instead of trying to eliminate the internal combustion engine, it redesigned it from the ground up so it could run on a fuel far cleaner than diesel while still keeping everything the trucking industry loves about combustion engines: durability, an existing repair network, and the ability to refuel in minutes instead of hours. That company is Cummins, a name connected to heavy-duty diesel engines in North America since 1919. Instead of fighting the clean fuel transition, Cummins chose to ride it with a strategy called multi-fuel, a single engine platform that can shift between diesel, natural gas, and eventually hydrogen by changing the cylinder head. But to understand why this matters so much, we need to look at the core of the entire story. The heart-called X15N. That platform is officially called HELM, short for higher efficiency, lower emissions, multiple fuels. The idea is very simple on paper. Build one shared base engine block that uses most of the same components below the head, then customize the cylinder head and fuel system for each specific fuel type. That lowers production costs, reduces maintenance complexity, and allows trucking companies to service the vehicle at any Cummins dealer across the country without having to retrain the entire technician workforce. The first member of the HELM family is the X15N, a 15-liter natural gas engine that Cummins calls the industry's first large-bore natural gas engine for heavy-duty trucks. The most important numbers are these: up to 500 horsepower and 1,850 pound-feet of peak torque, making it the most powerful natural gas engine ever seen in the truck market, strong enough to pull loads that only diesel used to handle. Unlike diesel engines, which ignite fuel through compression pressure, the X15N is a spark-ignited engine, similar to a gasoline engine but on a massive scale. This used to be the weakness of earlier natural gas engines. Spark plugs wore out quickly, and turbochargers could fail under harsh operating conditions. Cummins admitted that it learned those lessons from the X15N's predecessor, the 12-liter ISX-12N, and used all of that experience to improve materials, cooling systems, and turbocharger design for the new generation. The result is that the X15N delivers about 10% better fuel efficiency than its own predecessor. In September 2024, Cummins officially moved the X15N into full production at the Jamestown Engine Plant in Lakewood, New York, a facility that has existed since 1968. This was not some brand new factory suddenly rising out of the desert. It was a plant more than half a century old, backed by a $452 million investment to transform it into the production home of the industry's first multi-fuel platform. And here is a symbolic detail. The 2.5 millionth engine to roll out of that plant right on its anniversary was an X15N. And this is not an engine that only runs in a laboratory. UPS has installed the X15N in its Kenworth T680 fleet operating in Salt Lake City, Utah, an area whose air quality has long fallen below federal standards. Wegmans and Clayson Group, a Canadian trucking company, have also put the engine into real-world operation across different terrains, from flat American roads to brutal Canadian grades. One UPS driver said the driving experience felt almost no different from diesel, except the cabin was much quieter. Economically, each diesel gallon equivalent of compressed natural gas costs about $2.9, compared with about $4 for 1 gallon of diesel, according to data from the United States Department of Energy. The trade-off is that the truck travels slightly fewer miles per unit of fuel than diesel, but with tanks behind the cab holding up to 175 diesel gallon equivalents, plus auxiliary tanks, an X15N truck can still travel around 800 miles or more between refueling stops, enough for most real long-haul routes. At first, this may sound simple, like just another natural gas engine. But this small detail, the idea of using one shared platform for multiple fuels, may be the thing that changes the whole game. The next chapter, almost nobody is watching. Most people who follow the trucking industry stop at the X15N and assume that is the whole Cummins story, but the X15N was never the final destination. It was only the first brick in a platform designed to go much further. Back in 2022, Cummins announced another member of the HELM family, the X15H, a 15-liter engine that runs completely on hydrogen. The important difference, and this is the detail that so many tech videos miss, is that the X15H is not a hydrogen fuel cell like the one Nikola pursued. It is an internal combustion engine that burns hydrogen directly inside the cylinders, almost the same way the X15N burns natural gas, except with a different gas going in, That difference sounds small, but technically and economically, it is a huge gap. A hydrogen fuel cell needs a cell stack made from rare materials, and it is extremely sensitive to humidity, temperature, and hydrogen purity. It also needs an electric motor and a buffer battery behind it, which basically means rebuilding the whole powertrain from scratch. A hydrogen internal combustion engine, on the other hand, uses almost the entire mechanical architecture already proven through millions of miles of operation by the X15N and the diesel X15 family. It mainly changes the cylinder head and the fuel intake system. Cummins does not need to reinvent the wheel. It only needs to change the fuel flowing through a structure that has been optimized for decades. Here is the truth that is not talked about enough. The X15H already had real customers before the first engine ever rolled off the line. Werner Enterprises, one of the largest trucking companies in North America with more than 10,000 vehicles in operation and headquarters in Omaha, Nebraska, signed a letter of intent to buy 500 X15H engines as early as 2022. Transport Enterprise Leasing and Versatile were also on the list of companies that made similar commitments. Terex Advance, the concrete mixer manufacturer, signed an agreement to integrate the X15H into its Commander Series mixer trucks because the engine fits the harsh duty cycles that concrete mixers have to endure. Cummins' timeline for full production of the X15H is 2027, the same year the strictest emission standards take effect. And Cummins is not stopping at highway trucks. At ConExpo 2026, the company continued by introducing the next generation of the X15 engine family for construction, agriculture, and mining equipment, with power ranging from 400 to 700 horsepower and the ability to run on diesel, biofuels, or hydrogen from day one. That applies to excavators, mining trucks, bulldozers, and cranes. If everything goes according to plan, this would be the first time an engine manufacturer can sell customers 3 versions of the same engine block: diesel, natural gas, and hydrogen, all using the same assembly line, the same parts network, and the same service technicians. It is not as loud as the flashy electric vehicle launches, but it may be the most durable strategy in the long game. But no matter how good a technology sounds, it does not matter if it cannot be produced at scale, on schedule, and exactly as promised. The cracks behind the beautiful story. Up to this point, everything we have talked about sounds like a very clean and beautiful story. But if we only told the pretty part, this would be an advertisement, not an analysis video. So let's look at the real cracks that still exist. The first and biggest crack is this. The history of heavy-duty trucking is full of missed timelines. Tesla introduced the Semi in 2017 and promised production in 2019. That target slipped to 2020, then 2021, then 2022. And it was not until early 2026, almost a decade after the first reveal, that large-scale production officially started at the factory near Reno, Nevada. If a company with Tesla's capital and media attention still needed 8 years to turn a promise into a real production line, then Cummins' 2027 target for the X15H also deserves the same skeptical eye, even though Cummins does have the advantage of not building the technology from zero. The second crack lies in the fuel itself. Most hydrogen produced in the world today still comes from natural gas through a process that creates a significant amount of carbon emissions, often called gray hydrogen. For the X15H to be as green as promised, the industry needs green hydrogen, produced using renewable electricity at a scale large enough and a price low enough to matter. That is a massive infrastructure problem, far more expensive than simply adding more natural gas fueling stations, which already have a fairly broad network in North America. The third crack is the obvious lesson from a rival that already fell. Nikola, the company that bet everything on hydrogen, not hydrogen combustion like Cummins, but hydrogen through fuel cells, filed for Chapter 11 bankruptcy in February 2025 after failing to find a buyer or enough funding to keep operating. Its plan to build a hydrogen fueling network called Hyla in California collapsed with it. By the end of 2025, the company had only 1 employee left. The lesson here is not hydrogen does not work. The lesson is that the distance between a flashy demo and a stable product operating across thousands of trucks is always much farther than ambitious startups once believed. Even the X15N, the engine that has already proven itself in the real world, still has undeniable trade-offs. Lower range per unit of fuel than diesel, higher upfront cost for the truck and fuel tanks, and the fact that Cummins spent years with the previous engine solving spark plug and turbocharger durability problems under harsh operating conditions, issues that have only been meaningfully improved in the X15N generation. And finally, there is one risk no engineer can control: policy. The 2027 emission standards are the main force pushing the whole industry to act. But those standards are set by federal and state agencies, and those agencies can change direction whenever political power changes. If regulatory pressure weakens, the economic motivation to move from diesel to any cleaner technology, including the X15N or X15H, weakens with it. And this is where the race gets even more intense, because Cummins is not the only player trying to dominate the future. 3 big games, and nobody has won yet. Looking at the big picture, the race to decarbonize heavy-duty trucking is really 3 separate games running at the same time. And by mid-2026, none of those games has a clear winner. The first game is battery electric, with Tesla as the most visible representative. After almost a decade of delays, in March 2026, Tesla finally started large-scale production of the Semi at a new factory built next to Gigafactory Nevada, with a maximum planned capacity of 50,000 trucks per year. The 500-mile range version is priced at around $290,000, while the standard version costs around $260,000, and it is being promoted as the cheapest Class 8 electric truck on the market. DHL and UPS have both placed orders. Yes, UPS, the same company already operating Cummins X15N trucks in Salt Lake City, is also a Tesla Semi customer. That clearly shows that big freight companies are not betting everything on one technology. They're testing several paths at the same time. The second game is hydrogen through fuel cells, and this is the game that just suffered a painful fall. Nikola, once valued at nearly $30 billion after going public in 2020, went bankrupt in February 2025. Its assets were later sold to several different buyers, including the sale of its Arizona factory to Lucid Motors, another electric vehicle company. This bankruptcy does not mean hydrogen fuel cells are completely dead, but it is a very clear warning to anyone who thinks this path is easy. The third game, the one that receives the least attention from mainstream media, is hydrogen internal combustion, exactly the direction of the X15H. And interestingly, Cummins is not alone in this game. In Germany, a research group at Otto von Guericke University, led by Professor Hermann Rottengruber, recently announced a single-cylinder hydrogen test engine that achieved indicated thermal efficiency of more than 60%, an impressive academic number, even though it is still far from a commercial product. The parallel rise of an independent research direction in Europe shows that hydrogen combustion is not just Cummins' isolated idea. Multiple players are starting to see it as a viable path with lower technology risk than fuel cells. And do not forget the traditional players still standing there: Volvo, Daimler with its Freightliner brand, and PACCAR with Kenworth and Peterbilt. All of them still sell hundreds of thousands of diesel trucks every year, and all of them have their own electric or alternative fuel programs. One interesting detail is that Peterbilt and Kenworth, the two PACCAR brands, are also the chassis partners for Cummins' X15N engine, making the line between competitor and partner in this industry much blurrier than clickbait videos usually make it sound. So in the end, the biggest question remains: is Cummins' multi-fuel strategy really strong enough to change the future? If everything goes according to plan, and if it does not, at this point, let me make one thing clear again. Everything we have covered so far, from the X15N specs in the Jamestown plant to Werner Enterprises agreement, Nikola's bankruptcy, and Tesla's production line, is confirmed as of the time this video is being made. But from here on, we are moving into speculation, possible scenarios over the next few years based on current trends, and nobody, not even Cummins, can guarantee them for sure. Let's imagine the favorable scenario first. If the X15H launches on schedule in 2027, And if Werner Enterprises and other partners actually receive the 500 engines they signed letters of intent for, Cummins will have something that both Tesla and Nikola lacked when they were starting out: an existing network of service centers, parts, and trained technicians built from decades of selling diesel and natural gas engines. A hydrogen truck that breaks down on the road could be repaired at any Cummins dealer instead of needing an entirely new service network built from scratch, something Nikola never had enough time or money to complete. If that happens, the line between a clean truck and a normal truck could blur very quickly, because to the operator, it would still just be a truck, only with a different fuel in the tank. It is also possible that if natural gas and hydrogen costs remain consistently lower than diesel, large freight companies will have an economic reason, not just a regulatory reason, to switch fleets. That could turn emissions reduction from a compliance obligation into a real competitive advantage. In theory, that could lower freight transportation costs over the long term, affecting the price of everything from food to consumer goods transported by truck. But we also have to put the less favorable scenario on the table. If the 2027 emissions policy is loosened or delayed under a different administration, the mandatory push to transition will weaken, and many freight companies may choose to keep using diesel longer than expected simply because it is familiar and cheaper in the short term. If green hydrogen production infrastructure does not grow quickly enough, the X15H could launch on time mechanically, but still lack the clean fuel supply needed to truly stand apart from diesel in life cycle emissions. And if battery prices keep falling like they have over the past decade, while Tesla actually reaches 50,000 trucks per year as planned, electric trucks could dominate short and medium-haul routes, pushing hydrogen combustion into a smaller niche than expected. Only the longest, heaviest routes where batteries still cannot compete. One thing is almost certain: there will not be a single technology that wins absolutely on every route. Heavy-duty transportation is too diverse, from city delivery trucks to cross-country container haulers, for one solution to fit everything. The real question is not which technology will win, but which technology will capture the biggest share of the market. And Cummins, with a strategy that does not bet everything on one horse, is in a pretty unique position to benefit no matter how that market gets divided. So, after everything we have just gone through, what is really worth remembering? The most important takeaway may be this: while the world focused all its attention on the loudest promises, battery electric with its flashy launches, hydrogen fuel cells with valuations that shocked Wall Street, a quiet engine company that rarely appears in tech headlines chose a more modest path, improving something that already exists instead of trying to reinvent everything from scratch. By mid-2026, that modest path is the only one among the three main directions that has actually hauled real freight, made real money, on real routes, while one rival went bankrupt and another has only just started production after almost a decade of delays. But as we made clear earlier, that does not mean Cummins has won. The X15H is still a promise for 2027, not an engine already rolling down the highway. Green hydrogen infrastructure is still a massive unsolved problem. Emissions policy can shift at any moment with the political winds. And the history of this industry, from Tesla's 8-year delay to Nikola's collapse, has taught us one very clear lesson. The distance between an ambitious announcement and a truly reliable product on the road is always longer than press releases want you to believe. Right now, nobody can say for sure whether Cummins' multi-fuel strategy will become the way the heavy-duty trucking industry operates for the next 20 years, or whether it will simply be a useful bridge before batteries and hydrogen fuel cells finally figure out how to overcome their current limits. What happens between 2027 and 2030 when the X15H, if it arrives on time, actually starts rolling? And when Tesla tries to prove that 50,000 trucks per year is more than just a presentation slide, could decide which way the balance tilts. So what do you think? Between the three games, battery electric, hydrogen fuel cells, and Cummins-style hydrogen combustion, which one would you bet on to dominate heavy-duty trucking over the next decade? Or do you think there will be no absolute winner, and each technology will take over a different part of the market? Leave your thoughts in the comments below, and if this video helped you see one corner of this fast-changing industry more clearly, A like and a subscription would give the channel more motivation to keep making deep analysis videos like this in the future.